Welcome, YouTubers, to another episode in my Grammar Hero series. In today's video, I'm going to be working on some practice problems from an arithmetic reasoning practice test, which is one of the subtests that appear on the Armed Services Vocational Aptitude battery. That is the ASVAB. More specifically, I'm going to be working out 7 different practice problems, which correspond to videos that I've uploaded over the course of the last week and a half. In the description of this video, you'll see that each question is going to correspond to a topic, and next to that topic, there's going to be a link to that video where I discuss that topic at length. So in light of that, if you struggle with any of the questions in this video, just bear in mind that you can get more help just by clicking on one of those links and watching the video about that topic. Moreover, I want to mention that there are only 7 questions in this practice test because I've only covered about a third of the topics that appear on the arithmetic reasoning subtest. Once I cover all those topics, the next few practice tests I upload are going to be longer. In light of the fact you're not allowed to use a calculator or a reference sheet on the ASVAB, I strongly encourage you to avoid using those resources as you work on this practice test. And in order to get the most out of this practice test, I strongly encourage you to make an effort to work out these questions on your own scratch paper. That is, after I read a question, you should pause the video, attempt to work it out on your own, and then resume playing the video to see if you and I came up with the same answer. So all those things being said, let's go ahead and get started. Question 1 says, the temperature in Hot Coffee, Mississippi during a 3-day weekend was 97 degrees, 100 degrees, and 103 degrees. Of course, that's in Fahrenheit. You are trying to describe how hot it was to your friend who lives in Iceland, where they use Celsius instead of Fahrenheit. What was the average daily temperature of the town for the weekend in terms of Celsius? So in this problem, we have to figure out 2 things. We have to find the average of the daily temperature during the weekend, and then we're going to have to take that average and convert it from Fahrenheit, which it's given in, to Celsius for your friend in Iceland. So let's start by working on finding out what the average is. Again, average is the same as mean, and average can be found by taking the sum of the temperatures in this case. So we're going to do sum of temps, and that's going to be divided by the number of days in this case. Okay, let's go ahead and identify those things and plug them in accordingly. The temperatures are 97, 100, and 103, so let's sum those up. That's going to be 97 plus 100 plus 103. Of course, we know it's a 3-day weekend, so there are 1, 2, 3 days. So that's all going to be over 3. And in an effort not to make any mistakes, let's go ahead and sum these up off to the side. Let's do 103, 197. 7 plus 3 is 10, carry our 1. 9 plus 1 is 10, so we drop down a 0 and carry our 1. 1 plus 1 plus 1 is 3. So this becomes 300 over 3. We should know that 300 divided by 3 is simply 100. And this is the temperature in terms of Fahrenheit. Again, according to the question, we want to figure out what the temperature is in terms of Celsius. So we're going to have to take this temperature and convert it to Celsius using the formula they gave us. Notably, Celsius equals 5/9 times Fahrenheit minus 32. So we'll take this 100 degrees Fahrenheit and plug it in place of F here. And we'll do that arithmetic to solve this one. So this is Celsius equals 5/9. Fahrenheit is 100. Of course, that's minus 32. According to the order of operations, we do what's in parentheses first and then multiplication next. So we're going to do 100 minus 32 as our first step. Many of you could do this in your head, but I'm going to be working out every step in this video given that I don't know the backgrounds of the people who are watching this video. So we're doing 0 minus 2, which we can't do, so we're going to have to borrow. If we look to our left, we see that we have a 0 there, so there's nothing we can borrow. We're going to have to come all the way over here and borrow from this 1. This 1's going to become 0, and then this 0 is going to become 10. I'm going to have to borrow one more time now. This 10 is going to become 9, and this 0 is going to become 10. 10 minus 2 is 8. 9 minus 3 is 6. So we can see that, in other words, 100 minus 32 is in fact 68. So this is 5/9 times 68. Once we figure this out, we'll have made that conversion and be done with this one. That said, as we can see, we're doing multiplication, albeit with a fraction as well as a whole number. In order to do this, we're going to have to place 68 over 1, that is, write it as a fraction. Again, to write any whole number as a fraction, you can just place it over 1. So if I wanted to write 5 as a fraction, I would just place it over 1, given that 5 divided by 1 is just 5. Right, to multiply fractions, you just multiply straight across. That is, this becomes 5 times 68 over 9 times 1. And let's get rid of this work. So let's work this out. We have 5 times 68, 9 times 1. 9 times 1 is easy enough to do. That's just 9. 5 times 68, let's work that off to the side. And let me put 68 first. 5 times 8 is 40. Drop down your 0, carry your 4. 6 times 5 is 30, plus 4 is 34. So we can see this becomes 340 divided by 9. Again, we can regard fractions as long division, so we can regard this more specifically as 340 divided by 9. And we can do this long division to figure this one out. 9 goes into 3, it doesn't. 9 goes into 34 3 times without going over. 9 times 3 is 27. 34 minus 27 is 7. We have to drop down this 0. 9 goes into 70 7 times without going over, given that 9 times 7 is 63. 70 minus 63 is 7. Drop down an imaginary 0. When I add that imaginary 0, I have to bring a decimal up here. 9 goes into 70 7 times without going over. 9 times 7 is 63. 70 minus 63 is 7. Add a 0. 9 goes into 77 times without going over. 9 times 7 is 63. So we can see this is going to repeat over and over again. So this is 37.7 repeated. And I'm going to round this. So this is 37.777 repeated. I'm going to look at this 7 right here. I'm going to look at this number right here. If this number to the right of this 7 is 5 or greater, we can round up. And since it's 7, we can round this up to 37.8. And that's going to be our answer. So the average weekend temperature in terms of Celsius was 37.8 degrees Celsius, which is what you can now tell your friend in Iceland. So the answer to this one is C. And again, on the ASVAB, they're going to combine a lot of different things into one problem. You're going to have to be able to figure out an average, convert that to Celsius, and then use some your knowledge of fractions and long division to solve this one. Okay, so pretty challenging problem in light of the fact we had to do all those things. All right, let's take a look at number 2. It says, during a 2,000-mile road trip across the country, you drove an average speed of 50 miles per hour. During your 2,000-mile return trip home, you encountered inclement weather, so you drove at an average speed of 40 miles per hour. How long did it take you to complete the entire trip? So in this case, it should be obvious that we have all the elements of the distance formula. That is, distance equals rate times time. In case you haven't seen this in a while, distance refers to the length of the trip, R stands for the rate, and T stands for the time the trip took. So in this case, we should realize that we're going to have to apply this distance formula twice. Once for the trip across country. So I'm going to call this over here across country. And then once over here for your return trip home. Okay, so let's go ahead and start setting up these two iterations of the distance formula. So let's start by writing the distance formula for each of these. And let's scan this word problem one more time to see what we have in terms of the cross-country trip. We have the fact that it was 2,000 miles, so that's going to be our distance. And we completed that trip at an average speed 50 miles per hour, so 50 is going to be our R. So let's plug that into this cross-country side. That's going to be 2,000 equals 50 times t. And what this distance formula enables you to do is to find any value as long as you know the other two values. So if you know distance and rate, you can find time. If you know rate and time, you can find distance. And if you know distance and time, you can find rate. In this case, we have distance and rate, so we can see it's going to tell us how long this trip took. All right, let's fill in this other side. And I don't know why that's there. Let's just cross it out real quick. Let's see what we have in terms of our return trip. We have the distance, 2,000 miles. And we have the speed, our rate of 40. So let's plug those things in. Distance again is 2,000 miles. The rate was 40 according to the problem. And we can see we're going to be able to solve for time using those two things. Let's work these out one by one. To get t by itself in this case, I'm going to divide both sides by 50. This is going to cross out, leaving me with just t on this side. Let's cross out corresponding zeros. So this is going to be 200 divided by 5. I know 20 divided by 5 is 4. Therefore, 200 divided by 5 is going to be 40. In other words, this cross-country trip took 40 hours. Let's do the same thing over here. Let's divide both sides by 40 to get t by itself. This is going to cross out, leaving us with just t on this side. Cross out our corresponding zeros to make this a little bit easier. 200 divided by 4. Well, I know 20 divided by 4 is 5. Therefore, 200 divided by 4 is going to be 50. In other words, this return trip home took 50 hours. If we combine our times, we can see that's going to be the total trip took 40 plus 50 hours, or 90 hours. So the answer to this one is C, 90 hours. All right, number 3 says a store sells Christmas decorations at a 20% discount. And this should say in the month of January. If the store is selling a box of decorations for $24.40 on January 20th, what was the original price of decorations? Okay, so in this case, it should be obvious we're dealing with a percent change problem. And we should see that our percent change is going to be 20%. And that's going to be a discount. So we know this is going to be negative. Again, we know the new price of the decorations is $24.40 after discounts applied. And we want to figure out what the original price was. So in the video where I discussed percent change, I mentioned this formula. Percent change equals new price minus old price over old price times 100. By filling these values in correctly into the percent change formula, we'll be able to figure out whatever's missing. In this case, we know, as I just mentioned, the percent change was a 20% discount. Discounts are negative in the percent change formula, so this is going to be negative 20 over here. We know the new price of the decorations after the discounts applied. So that's going to be, in place of n, we're going to have 24.40. So that's going to be 24.40. All right, and now we just got to fill in the rest of this formula. Now I'm going to take a step back and just call this x to make it a little bit easier. So instead of O, I'm just going to write x. So this is going to be 2440 minus x over x times 100. Now by solving this equation for x, we'll be able to figure out what the original price of the decorations were. So let's go ahead and do that. As my first step, I'm going to divide both sides by 100, which is going to enable me to cross this out. So this is going to become, on this side, 2440 minus x over x equals negative 20 over 100. Negative 20 over 100, we should be able to realize mentally is negative 0.2. Okay? So as my next step, I want to get rid of this x out of the denominator. So I'm going to multiply both sides by x. This is going to cross out, leaving me with 2440 minus x over here equals negative 0.2 x on this side. Let's add x to both sides. And again, if it's helpful, you can think about this as 1x. So let's add 1x to both sides. This is going to cross out, leaving you with 2440. Negative 0.2x plus 1x is negative 0.8x. Or it's just positive 0.8x. Again, that's negative 0.2x plus x is going to be 0.8x. Sorry about that. Now to solve for x, we're just going to divide both sides by 0.8. This is going to cross out, leaving you with x. And as we can see, x equals 2440 divided by 0.8. And again, we can regard fractions as long division. So let's write this as 2440 divided by 0.8. As far as doing long division with decimals goes, you can do it as long as there's no decimal outside the division bracket. In this case, 0.8 is a decimal and it's outside the division bracket. So prior to doing this arithmetic to solve this via long division, we're going to have to make some adjustments accordingly. That is, we're going to have to shift this decimal place one time to the right to make 0.88. Then we're going to have to shift it a corresponding number of times inside the division bracket to mirror what we did outside. So in reality, I'm working on this problem, 244.0 divided by 8. Okay, now we can actually solve this one, and it's fairly easy. 8 goes into 24 3 times without going over, given that 8 times 3 is 24. 24 minus 24 is 0, but we got to drop down this 4 as well as this 0. And of course, we're going to keep this decimal right in place. Now the question is, how many times does 8 go into 4? It doesn't. So we're going to have to put a 0 right there. Now the question is, how many times does 8 go into 40? That's going to be 5 times. 8 times 5 is 40. 40 minus 40 is 0. So we can see in this case, x is 30.5, which in terms of dollars and cents is $30.50, which is going to be A. So we know that the original price, in other words, of the Christmas decorations was $30.50. Okay, so that's this one. And again, I have a whole video devoted to percent change. I think it's about an hour long, and in that video, I do all the variations that you'll see of percent change problems. So if you need more help with this, go ahead and take a look at that video. All right, number 4 says, on a map, the scale indicates that 1/2 inch represents 200 miles. If the distance measured between the German cities of Wankendorf and Poppenweiler is 4 inches, what is the actual distance between the two cities? Okay, so In order to solve these scale problems, you should realize that we're going to need a proportion. And when I solve proportions, I like to group what they give me on the left-hand side of the equal sign, and then everything I'm trying to solve for on the right-hand side of the equal sign. So in this case, I'm going to set up my proportion by writing 1/2 inch over 200 miles equals, and we're given 4 inches over here, so we know we can put 4 inches in the numerator of this proportion over x miles. Okay, so this is how we would solve this one. We set up a proportion, and now to solve proportions, it should be pretty clear that you cross multiply. So let's do 1/2 times x to start. This will be 1/2 x, and we'll drop out the measurements as we do this algebra here. So 1/2 times x is 1/2 x, and then we have 200 times 4. Okay, let's keep working this out. 1/2 x equals 200 times 4, which is 800. Now we're trying to get x by itself, so in order to get rid of this 1/2, I'm going to multiply both sides by 2. This will cause this fraction to cross out, leaving you with just x. 800 times 2 is going to be 1600. And of course, we can see x corresponds to miles, so we know our units is miles. So the answer to this one is B, 1600 miles. That 4 inches corresponds to 1600 miles of a 1/2 inch corresponded to 200 miles. And we solve that using a proportion. Again, in the description of this video, there's a link to a video, which is about an hour long, where I talk about proportions for an hour. So, all right, number 5 says, there are 8 horses in a race: Sir Barton, Big Brown, Apollo, American Pharaoh, Assault, Citation, Flying Ebony, and Omaha. If all we're concerned with are the first, second, and third place finishers, i.e. the trifecta, how many different orders of finish are possible? Okay, so this question is somewhat challenging, but if you watched my video on permutations, combinations, and factorials, you should realize that this is going to require a permutation to solve. Again, a permutation is how you solve combinations where the order is important. In this case, we should see that we're interested in figuring out how many possible first, second, and third place finishes are possible. So that first, second, and third place is going to be significant. So let's set up a permutation to solve this one. And again, that's going to be noted by P. And then we do n r equals n factorial over n minus r factorial. And n refers to the total pool. So in this case, there are 8 horses. So I know n is going to be 8. R refers to the subselection from that pool. And we can see there's 1, 2, 3. So we know R is going to be 3. Let's plug things in accordingly. So n is 8. So this is 8 pick 3 equals, as we can see here, n is 8. So let's plug that in for n factorial. This is 8 factorial over n minus r. That's going to be 8 minus 3 factorial. Let's not do that just yet. So this is 8 factorial over 8 minus 3 factorial, which is going to be 5 factorial. Now let's work this out. This is going to be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And this is going to be 5 times 4 times 3 times 2 times 1. And my pen's starting to act up. All right, as we can see, we can cross out what corresponds in the numerator and the denominator. So everything 5 on down we can cross out, which just leaves us with 8 times 7 times 6. 7 times 6, we should know, is 42. So that leaves us with 42 times 8. So let's work that off to the side. 42 times 8. 8 times 2 is 16, carrier 1. 8 times 4 is 32, plus 1 is 33. So in other words, given these 8 horses and the fact that we're only interested in figuring out how many ways they can come in first, second, and third, we should realize that there are 336 different orders possible, and we solve that using a permutation, and specifically we did an 8-pick-3 permutation. And again, there's a link to that in the description of this video. Number 6 says an Olympic-sized pool can be filled by pipe 1 in 2 hours and by pipe 2 in 4 hours. There's also a drain pipe that drains the entire pool in 5 hours. If the valves of pipe 1 and pipe 2, as well as the drain pipe, are open, how long will it take to fill the pool? So this is what's called a combined work problem. And if you watch that video, you'd understand that to solve these, we use the formula T over A plus T over B equals 1, where A refers to the time it takes one thing to do the job by itself, B refers to the time it takes another thing to do the job by itself, and T refers to the time it takes for both things to do the job working together. 1 refers to the one job that they have to complete. In this case, however, we can see that we have pipe 1, pipe 2, and a drain pipe. So to solve this one, we're going to have to make some minor modifications to this combined work problem. I'm going to let pipe 1 be A, I'm going to let pipe 2 be B, and I'm going to let the drain pipe be C. So let me go ahead and account for C in this formula. This drain pipe is taking water out of the pool, whereas these other 2 pipes are adding water to the pool. So instead of being addition here, it's going to be subtraction. Again, it's taking water away while these other 2 are adding to the pool. Again, it's going to be T in the numerator and C in the denominator equals 1. So I just went ahead and accounted for that third drain pipe by adding T over C to this formula. Again, A, B, and C refer to the times it takes each of these to do the work by themselves. We can see pipe 1 takes 2 hours, so that's going to be T over 2. Pipe 2 takes 4 hours to fill the pool by itself, so that's going to be T over 4. And according to the problem, the drain pipe takes 5 hours to drain the pool, so that's going to be minus T over 5 equals 1. Okay. Now, as you can see, we're just adding and subtracting fractions here. So in order to proceed, we're going to have to take these fractions and place them over a common denominator before we can actually add them and subtract them. So if it's helpful, you can list out the factors of each of these. We have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. That should be enough to find a common factor. We have 4, 8, 12, 16, and 20. We can see that 2 and 4 have a common factor of 20. And then we have 5, 10, 15, and 20. And we can see that 2, 4, and 5 all have a common factor of 20. So that's going to be our denominator for all of these. So we know we're going to be rewriting these fractions such that we put 20 in the denominator. Okay, to make 220, we have to multiply 2 by 10. And what we do to its denominator, we're going to do to its numerator. 2 times 10 is 20. 10 times t is 10t. To make 420, we have to multiply it by 5. We're going to have to do that to the numerator as well as the denominator. Again, 4 times 5 is 20. 5 times t is 5t. And finally, to make 520, we have to multiply it by 4. what we do in the denominator, we're going to have to do in the numerator as well. 5 times 4 is 20. T times 4 is 4t. Okay, so now that we have these fractions over a common denominator of 20, we can go ahead and combine them into one big fraction. So this becomes 10t plus 5t minus 4t. Okay, let's combine these like terms. 10t plus 5t is 15t. 15t minus 4t is 11t. Of course, that's over 20 and equal to 1 still. Again, we want to get t by itself. So as our next step, we're going to have to multiply both sides by 20. This is going to cross out, leaving us with 11t over here equal to 1 times 20, or just 20. All right, let's divide both sides finally by 11 to get t by itself. We can see t equals 20 divided by 11. Again, we can regard this fraction as long division, which will give us its decimal. So we're going to do 20 divided by 11. Now we're asking ourselves, how many times does 11 go into 20 without going over? That's going to be 1 time, given that 11 times 1 is 11. Subtract. 20 minus 11 is going to be 9. 11 doesn't go into 9, so we have to add an imaginary 0 there. When we add that 0, we're going to have to bring up a decimal right here. 11 goes into 98 times without going over. 11 times 8 is 88. 90 minus 88 is 2. Bring in an imaginary 0. 11 goes into 20 one time without going over. 11 times 1 is 11. Subtract. 20 minus 11 is 9. So as you can see, this is going to repeat 0.81818181. On the ASVAB, it's common for you to have to round. So in this case, we're going to take 1.81, and we're going to round this number right here. That is the tens. So we're going to look at this 1 right here. If this number is 5 or greater, we round up. If it's 4 or below, we just keep it the same. So this is 1.8. So in other words, if all these pipes are open, it's going to take 1.8 hours to fill this pool, which is B in this case. Okay. All right, and finally, we can see 7 says Sally receives the following scores on her math test: 78, 92, 83, and 99. What score does she need on the next test in order to have an average of 90 in her math class? So in this case, we're going to be working with averages again. Again, that formula is average equals the sum of all the data points over the number of data points that there are. Let's plug in what we have and what we need. We know that she wants to have a 90 average. That is, her average has to be 90. So we know this average over here has to be 90. We're told that according to the word problem. We know that her test grades are 78, 92, 83, and 99. We're told we want to know what she needs on her next test in order to have a 90 average. So I'm going to represent that next test as X. Okay? So in total, she'll have taken 1, 2, 3, 4, 5 tests. So in total, she'll have 5 tests, so we'll put that as our number of tests in the denominator of this formula. And now, as you can see, we're just solving for X in this case, and X will refer to that test on her next, the grade on her next test. So let's go ahead and do that. To start, I'm going to multiply both sides by 5. This will cross out here, leaving me with 78 plus 92 plus 83 plus 99 plus X equals 90 times 5. Well, 9 times 5 is 45. Therefore, 90 times 5 is going to be 450. And now that we've done that, let's go ahead and sum up all these like terms over here. That is, let's add, and I'm going to do it off to the side here. Let's add 78, 92, 83, and 99 together. And be very careful as you do this, because the arithmetic reasoning subtest is hard because it's very easy to write the wrong sign and make a mistake. So we have 8 plus 2, which is 10, and then 9 plus 3, which is 12. So this is going to be 22. We're going to carry our 2 here. Let's go ahead and see what this is. This is going to be 8 plus 9, which is 17. 9 plus 7, which is going to be 16. 16 plus 2 is 18. So this is 18 plus 17. Let's work that off right here so as not to make any mistakes. 7 plus 8 is going to be 15. Carry our 1. 1 plus 1 plus 1 is going to be 3. So we can see that this is going to be 352. Let's add that in here. 352 plus x equals 450. And again, we're solving for x, so as our next step, we'll subtract 352 from both sides. And I'm starting to get a little sloppy because this practice test has been pretty challenging. This crosses out, leaving us with just x here. X, of course, as we can see, equals 450 minus 352. Let's work that off to the side. 450 minus 352. 0 minus 2 we can't do, so we're going to have to borrow. This is going to become 4, and this is going to become 10. 10 minus 2 is 8. 4 minus 5 we can't do. We have to borrow. This becomes 3. This becomes 14. 14 minus 15 is 9. 3 minus 3 is nothing. So this is 98. In math, it's customary to write the variable for which you solved on the left. So this is x equals 98. In other words, what's this lady's name? If Sally wants an average of 90 on her test, she needs to score a 98 on this next test to have that average. So that is it for this practice test. Admittedly, it was pretty challenging in terms of the amount of arithmetic we had to do, which is not surprising considering this is an arithmetic reasoning test. Regardless, I hope you found it helpful. You're more than welcome to leave some feedback in the comments section below. But on that note, I'm going to go ahead and cut you loose. Konnichiwa.